Whether you are a novice or a 10-year teacher, as long as your workshop has a lathe, so you won't be able to miss this video today. We will introduce how to use a lathe, the entire process of machining parts, and a lot of related skills about lathe machining. We will start with the tool settings, start explaining the sequence of programming and processing. The amount of content information is very large. Suggest everyone to save before watching. This is a particle part that we are preparing to process. It is a coaxial holder. There are multiple steps above, can be adapted to chuck or triangular chuck. The through-hole diameter of this part is 3/8 inches. The diameter of our indicator handle is also diameter. We will use a 3-inch diameter material. Make this part. The first step is to turn one side of it, then drill holes, then flip the workpiece, turning the other side, and turning 20 megameters, then place it on our double-axis washing, bed drilling, and company processing positioning screws. This is the drawing we need to refer to all lengths and diameters are marked on it. We can also use it to describe how the lathe moves. The point here is located at 0.5 inches. That is the position relative to the center line of the 0 point, but we usually don't call it x 0.5. The position of the tool here is zone inches because it's in this position. Cut out a section with a diameter of 1 inch, and we are currently operating a lathe, so all x values represent diameter. Let's put it in the lathe now. Generally speaking, the Z plus on the lathe represents the direction away from the spindle. Z minus represents the direction towards the main axis. X minus represents the movement trajectory towards the center line of the spindle. X plus represents the movement trajectory away from the center line of the spindle. Here is what we are about to do. Tools installed on the turret: 1 outer diameter turning tool, a center drill, and a drill bit. When installing longer drill bits or reamers, we will check along the handle. First, ensure that the tool holder is straight, then tighten it. Again, the precise position of the cutting tool and workpiece needs to be known on the lathe. We first set the tool offset. Use the indicator here to find the drill bit holder center on the x-axis from front to back. After finding the center point, let's take a look at the offset of the tool. Again, click on the X diameter measurement button, enter 0 in the diameter box because the tool is currently at the 0 point on the x-axis. Next, 1232 drill bit holder on tool 2 and tool 3. Repeat this operation. Now we can install the processing materials. Tighten the chuck. Let's talk about it. Here we are now simulating the first operation of this device. If this is really the first operation, never use your substitute wrench forgotten on the chuck. Next is the turning tool. Set the x-axis. Tool layout. For the turning pin tool, we will handle the outer diameter of the component in the positive direction of the z-axis, then measure the diameter of the component. Edit tool layout. Click on X diameter measurement. Enter the diameter length just measured as turning tool. Set z-axis tool setup. We need to first handle the z-axis plane of the component, then leave along the z-axis in the highlighted tool layout. Click on the z-axis plane measurement button. The current Z-plane is very smooth. We can use it as a benchmark. Set Z-axis offset. For each tool, bring the drill bit close to the surface of the component using gaskets or paper strips on one side. Determine if there is contact with the component. Let the tool slowly approach the surface of the component while doing so until the gasket cannot be moved on a plane in the tool offset of the highlighted tool. Click on the Z-axis plane measurement button. That's it. We have prepared for tool 2. Set the tool distance offset on the Z-axis, of course. We can also be in it. Subtract the thickness of the gasket used. Next, we will provide tool 3 or other drill bits. Repeat. The first step, we will use the workpiece offset under code 54. Open the tool offset page. Confirm that both the x-axis and z-axis values have been set to 0 for this workpiece. We need to tell the equipment the current position of the workpiece, that is, the workpiece bias component intersection of plane and main axis center line. It's the 0 point on the x-axis and the 0 point on the z-axis at the same time. It is also the location where we start the tool. We need to inform the device of this information. These contents introduced above very important in the setup steps. After setting the tool on the tool addition page, let's start introducing the core content of this video episode. No component programming in the controller. During programming, we usually need to refer to the data in the drawings. We will provide position information for all X and Z axes merged together. This looks much more convenient. Considering the raw materials here, we will add a few lines of cutting operations, importing and exporting code. This is the first step in our operation information required for programming definition of raw material size here. The starting point of the raw material is in the bottom left corner. We can see the extension instructions for each line in this column. We enter 3.0, enter 0.5 on this line again, so the raw materials are defined on screen. The rectangular area displayed as this green line frame, the fast-moving endpoint, refers to the endpoint before. Starting to turn the workpiece location reached by rapid movement, this point is very heavy. It will determine where the outer diameter rough turning starts. Starting from here, the workpiece will face downwards, processing to the left and both above and to the right are rapid movements. Today, this needs to be set at the outer edge of the raw material. If it's too high, it'll waste time because there was a section of the journey where nothing could be cut. If the setting is too low, the tool will be in the initial machining trajectory during operation, cutting off excessive material, so we input x3.1 and 0.1 at this moment. A miracle happened after we enter these values. The controller will automatically fill it out for us. Starting position on the z-axis. This is the starting point for machining shapes. This is what we are sharing with everyone. One of the most important lathe operations, whether you use VPs or manual programming. If an alarm is detected during rough driving cycle, just take a look here. Check the fast-moving endpoint and machining starting point. Ensure both the direct movement of the columns to axis position refers to, so we try not to make any changes here. For the starting point of the x-axis, we will input 0.62. So how is this value derived? The turning tool we use has a radius of 0.3 inches, approximately 0.8 millimeters. If you want to fully contact the surface of the cutting raw material, the blade needs to be moved below the center line. The moving distance is the size of the radius, and since all x values refer to diameter, so it must be moved to x 0.62 instead of negative x 0.0 cm. Regardless of the radius of the workpiece cutter head, we all need to clarify this point in the same program. Using metric units, this value is x 1.6, representing a blade radius of 8 millimeters. If the value of the turning tool in the program is x0, after completion of processing, a small tip will be left on the workpiece, unable to cut to the entire surface. This will cause the drill bit to slip or just leave a small tip. This is also before we write the program. Need to understand the reason for the blade radius. From now on, we can input it on the drawing. Due to time constraints, this video will be released in 2 installments. If everyone is interested, welcome to like and follow view subsequent videos.